In this tutorial we'll be talking about X-rays. Now X-rays are electromagnetic waves just like light, but they're from the 10 to 16 Hertz to the 10 to 19 Hertz range. Now this isn't particularly well defined, but the lower end or the smaller frequencies are generally considered soft X-rays, while the higher frequencies are called hard X-rays. Okay, I'll talk to you about a few detectors. Okay, you have a Geiger counter, you have a scintillator, also you have direct semiconductor detection, okay. And we're going to talk to you about Bremsstrahlung radiation. We have an electron firing in at a high Z nucleus, so high Z, which means large numbers of protons. So you're talking about 80 protons and above, where the electron comes in and gets distorted by the incredibly large electric field from the nucleus, and radiation gets sent off. This radiation is generally in the X-ray range. It's called Bremsstrahlung radiation. You also have a Bragg diffraction, where you have a crystal structure like so. The instant light comes in, goes out, comes in again and goes out. Now, just bear with me for a second. Call this angle here phi, or whatever else you would like. The distance between the atoms in the crystal structure we'll call d, and for these photons to be still in phase when leaving, say if they were in phase when they were coming in, to be in phase when they were going out, so that would be n times lambda, keep them in phase, equals to 2 d sine phi. Okay, as there would be a d sine phi over here and a d sine phi over here, so n lambda equals 2d sine phi. So how do we make X-rays? Well, say if we get a small, say 5 volts power supply, we just heat up a metal coil, heat up a piece of metal, and we attach the piece of metal over onto a bigger piece of metal, like so, and we put the voltage here of about 100 kilovolts. Okay, so 100,000 volts or above, but this will produce an awful lot of heat, so we'd have to cool it down with some form of oil, and water might not do because you boil off the water too quickly. So the electrons, we boiled off the metal, and they'd be accelerated very quickly towards this piece of metal, and X-rays will be given off, and that's how X-rays are formed in hospitals and like. Now it should be noted that you can't see X-rays directly by the eye, but when you're in a very dark room and you have a very strong X-ray source, the X-rays can be absorbed by the eye and re-emitted, and you'll see a bluish grey colour being emitted. So if you are randomly in a dark room and you see a bluish grey colour coming from someplace, that bluish grey colour is probably from a high energy X-ray source which is damaging your eye